Hello students, welcome to the class. So in the previous class, we had discussed around 50 questions regarding structure of atom. All the concepts we had covered in that. We had taken the concepts on quantum numbers. We have seen the concepts on all the models. It might be Bohr's model, it might be Heisenberg's uncertainty principle. And here we have another set of questions here. So moving with the 51 question, the total orbital angular momentum of a p electron is given as. So orbital angular momentum, how do we write orbital angular? It is for azimuthal quantum number. Yeah. So I can say orbital angular momentum. It is orbital angular momentum. If they say orbital comes for orientation, orientation comes for what? It comes for m, magnetic quantum number. It depends on azimuthal quantum number. So it depends on azimuthal quantum number. It is L into L plus 1 h by 2 pi. And this h by 2 pi, I can write it a constant as like this also. So this represents h by 2 pi. Okay, fine. Okay. So for what they have said for p electron. So I can consider for p electron, that is electron present in the p subshell, what is the value of L? L is equal to 0 for S subshell, S electrons, L is equal to 1 for P, L is equal to 2 for D, L is equal to 3 for F. So L is equal to 1. So let us substitute. Thus I can say M is equal to root of L into 1 into 1 plus 1 h by 2 pi. I'll keep h by 2 pi as it is. 1 plus 1 is 2. 2 into this is 2. Therefore, I can write this as root of 2 h upon 2 pi. Yes, or this can be also written as h upon root 2 pi. Squaring, so I'll get it h upon root 2 pi. Yes, so let us see which option contains. Yes, so it is h upon root 2 pi. Option A is the correct option. Next question. The total number of atomic orbitals in fourth energy level of an atom is. See, I have told you when I was discussing about the quantum numbers, what we have discussed there. For a shell, for a shell with principal quantum number n, total number of atomic orbitals, total number of atomic orbitals in any energy level or shell is given by, it is given by n square. It is given by n square. So what does this mean? If you want to find total number of atomic orbitals, how many atomic orbitals are present, then it is for a shell n, it is given by n square. So what they have said in our question, they have said fourth energy level. So fourth energy level means n is equal to 4. So total number of atomic orbitals, total number of atomic orbitals is equal to n square, and that is equal to 4 square, that is equal to 16. So the correct option is 16. Correct option B is the correct option. Correct. Okay. If n is equal to 6, the correct sequence for filling the electrons will be. The correct sequence for filling the electrons will be. So they are saying n is equal to 6. Yes, it is 6. The correct sequence for filling the electrons. First, which orbital will be filled? It is sixth shell. So you can imagine n is equal to 1, 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f. Like that, n is equal to 6, 6s, 6p, 6d, 6f. So correct sequence for filling the electrons will be. So first, see, this is there. So I can say first ns and np, correct? So ns and np. So you can see here like this, like this, like this. Then we have 3D, 4P, 5S, then like this. So when you do this, when you see this proper format, what we will come to first NS, 6S, then 6P will not fill 60. If you observe 8, this will be N minus 1D first. It will be not 6D, it will be 5D. 5D first. Here 5D comes first. Then we'll go for 6P and all. Okay, then for NF, it will be 4D, 4F. That is N minus 2F. N minus 2F. Yes, therefore the correct sequence is NS. After that, N minus 2F. Then comes N minus 1D. And then comes NP. So this is the correct sequence. So in which of this following has got this sequence? The correct sequence is for option A. So it is option A. Getting? Okay. Next question. Maximum number of electrons in a subshell of an atom is determined by following. Maximum number of electrons in a subshell. All the questions on quantum numbers are very good number of questions. So for a given shell, subshell they have said. So for a given shell, my L is the subshell. Yes. So the number of subshells, how do we write? M is equal to, I had told you, 2L plus 1. This is the number of subshells. Yes. Since each subshell can accommodate how many electrons? 2 electrons of opposite spin. Yes, both the electrons will have opposite spin. That is, spin quantum number will be different. So maximum number of electrons in a subshell is equal to 2 into 2L plus 1. So here it is 2 into 2L plus 1. That is 2 into how much is L? Okay, L is not given. So I can write it as 4L plus 2. 4L plus 2. This is what we have already seen in our content. So 4L plus 2. So option D is the correct option. So for this, correct option is 4L plus 2. Next question. Which of the following is not permissible arrangement of electrons in an atom? So n is equal to 5, L is equal to 3, M is equal to 0, S is equal to plus half. N is equal to 3, L is equal to 2, M is equal to minus 3, S is equal to minus half. N is equal to 3, L is equal to 2, M is equal to minus 2, and S is equal to minus half. N is equal to 4, L is equal to 0, M is equal to 0, and S is equal to minus half. Let us see. So the question asked is, which of the following is not a permissible arrangement of electrons? In any atom, yes, for any value of n, we know that the values of L vary from 0 to n minus 1, right? The values of L vary from 0 to n minus 1. So for a given value of L, values of M vary from, how do they vary? Minus L to plus L, including 0, right? Including 0. And the values of S, so this is value of L, this is value of N, M, and this is for values of S, What will be the values of s? Plus half and minus half, right? Yes. So if you see first option, n is equal to 5, l values is 3, l is equal to 3 and m is equal to 0. That is correct. Look at option B. For option B, n is equal to 3. Then L is equal to 2 they are saying. If L is equal to 2, M values vary how? M values vary from -2, -1, 0, +1 and +2. But they have given M is equal to -3, which is not possible. Which is not possible. And S might be plus half or it might be minus half. Doesn't make the difference, right? So this is not possible for if L is equal to 2. Look at the other options. Look at option A. N is equal to 5 and L is 3 they are saying. So M values vary how? M values vary from -3, -2, -1, 0, +1, +2 and +3. So M is 0. So 0 is present. And yes, they have given. Look at option C. N is equal to 3. L is equal to 2 they have said. So M values vary from -2, -1, 0, +1, +2. Option is there? Yes, 0 is there. Last option you see, N is equal to 4. L is equal to 0 they have said. So M value, it is 0. So 0 is there. It is given. But in option B, for L is equal to 2, M does not have -3 value. M does not have -3 value. So that is not permissible. That is not permissible. So M is equal to -3 for L is equal to 3 is not, L is equal to 2 is not permissible. Therefore, that is not the correct option. Correct? Next, the orientation of an atomic orbital is governed by, yes, which of the quantum numbers governs the orientation? We know what is the significance of principal quantum number. It tells us about the energy of the main shell and number of electrons in the shell in the main energy level, which is given by 2n square. Azimuthal quantum number tells us what? It tells us about the subshell and the shapes of the subshells. We know S subshell is dumbbell, P subshell is S subshell is spherical, P subshell is dumbbell, D subshell is double dumbbell, and F is complex. Correct? Spin quantum number tells us about the magnetic moment, that is spin of the electrons in the orbitals. One with plus half spin and another one is minus half spin. If one is spinning in clockwise, another will spin in anti-clockwise. Magnetic quantum number tells us about the orientation of the atomic orbitals. So orientation of the orbit, that means the number of orientations will tell how many atomic orbitals are present for the subshells. So if you consider S subshell, there is only M is equal to 0. So it is having only one orientation. For P subshell, M is equal to -1, 0 and +1. Therefore, there are three orientations. So three orbitals. Px, Py, Pz, and this is only S. For D, it is M is equal to -2, -1, 0, +1, +2. So it is having five orientations: dxy, dyz, dxz, dx square y square, and dz square. And for F, it is M is equal to -3, -2, -1, 0, +1, +2, +3. So 7 orientations. That means 7 atomic orbitals. So the orientation of the atomic orbital is governed by which quantum number? It is governed by magnetic quantum number. Correct? So magnetic quantum number. Next question. Consider the following set of quantum numbers. Okay, n is given, L is given, M is given, and S. So different values are given. Which of the following sets of quantum numbers is not possible? Okay, let us see. Fine. So first option, if you see, it represents what? See, first option, n is equal to 3, L is equal to 0, M is equal to 0, and S is equal to plus half. So it represents what? 3. L is 0 means what? It represents 3s orbital. Okay. Second option. N is equal to 2. L is equal to 2. M is equal to 1. And S is equal to plus half. Second option. If n is equal to 2, L values vary from 0 to n minus 1. So 0 to n minus 1. That means it should have 0 and 1 value. 2 is not possible. Not possible. Because values of L vary from 0 to n minus 1. Okay, so this is not possible. Let us see third option. N is equal to 4, L is equal to 3, M is equal to minus 2, and S is equal to minus half. So this is what? 4. If L is 4, 0 to n minus 1, so 3 is possible. So L is equal to 3 means what? It is F orbital. So it is 4F orbital. Correct? M is equal to minus 2, that is also possible. Fourth one, what is fourth one? N is equal to 1, L is equal to 0, M is equal to minus 1, S is equal to minus half. For n is equal to 0, L values vary from 0 to n minus 1. For L is equal to 0, M values vary how? Vary from minus L to plus L. So it should be, M should be 0 only. It cannot be minus 1. So this is also not possible. Correct? Fifth one, N is equal to 3, L is equal to 2, M is equal to 3, S is equal to plus half. Are you all getting? For N is equal to 3, L is equal to 2, that is correct. For L equal to 2, M values vary from minus L to plus L. So it should be minus 2, minus 1, 0, plus 1, plus 2. So here there is no 3. Here there is no 3. So again for L value equal to 2, I cannot have M equal to 3. So this is also not possible. So second is not possible. Fourth is not possible. And fifth is not possible. So second, fourth and fifth, all those are not possible. So which is the correct option? It is option B. Second, fourth and fifth are not possible. They are not which are the sets of quantum numbers which are not possible. Next, the following quantum numbers are not possible for how many orbitals? For how many orbitals the following quantum numbers are not possible? Okay, so here again, let us see. They have given quantum numbers n is equal to 3, L is equal to 2, M is equal to plus 2. For n is equal to 3, L is equal to 2 and M is equal to plus 2, it symbolizes what? So 3, L is equal to 2 means it is D. So one of the orientation of D. So I can say it symbolizes one of the 5d orbitals, correct? Of third shell. Yes or no? Of third shell. So one of the 5d orbitals of third shell. So we know that 5d orbitals 1, 2, 3, 4, 5. So m for 5 3, for 2 it is minus 2 minus 1 plus 0 plus 1 plus 2. So these are the 5d orbitals. So the question they have asked is the following quantum numbers are not possible for how many orbitals? So here it is possible for 2 orbitals, it is possible for 3 orbitals, it is possible for 4 orbitals also, but it is not possible for 1 orbital, m is equal to plus 2. So it is not possible for 1 orbital. So correct option is option A. It is option A. Yes. Next question. For which of the following set of 4 quantum numbers an electron will have highest energy? So they have given n, l, m and s values as so and so. So what we will do? We will calculate the n minus n plus l value for all of them. Yes, let me write it out. A, B, C and D. The more you practice it like this, the more it becomes easier for you all. So it is S value. For first option, it is 3, 2, 1 and plus half. Second option, it is 4, 2, minus 1 and plus half. Third option, it is 4, 1, 0 and minus half. Last option, it is 5, 0, 0 and minus half. So energy of the electron depends on what? So I can say here, energy of electron depends on the value of n plus L according to n plus L rule. Yes. So what are the subshells? A1, what is A subshell? Third shell, L is equal to 2 means it is D. Correct? Okay. B option. Fourth shell, L is equal to 2 means it is D. Third option, fourth shell L is equal to 1 means P. And last option, fifth shell L is equal to 0 means it is yes. So let me calculate N plus L value for all of them. So 3 plus 2 is 5, 4 plus 2 is 6, 4 plus 1 is 5, and 5 plus 0 is 5. Correct? Yes or no? Okay. So where energy is highest? All of them are having 5. So this is having 6. Therefore option B, energy is highest, I can say. But if they would have asked you arrange them. So in the decreasing order. So first comes 4D with highest energy. Highest energy. Why? Highest energy because N plus L value for 4D is 6. Then comes which one? If N plus L value for the orbitals are same, then you will consider the highest principal quantum number will have highest energy. So then comes what? Here it is 3D, 4P and 5S. So which comes? 5S comes. Then comes which one? 4P and last is 3D. This is in decreasing order. If it is in increasing order, 3D is having lower energy than 4P, which is having lower energy than 5S, which is having lower energy than 4D. Is that right? So here they have asked only which is having highest energy. So this is having highest energy according to N plus L rule. According to N plus L rule. So it is option B. It is option B. Electronic configuration of calcium atom is written as calcium atomic number is 20. So I'll write it as 1s2, 2s2, 2p6, 3s2, 3p6, 6 for 4 is 20, 10 plus 8 is 18. So 4s2. Yes. So this is complete electronic configuration. This is what? Complete electronic configuration. But here the options given are in condensed form. How do you write condensed form? You will take the inner shells. So inner shells are these and see the lower for atomic number 20, which is the lower noble gas, the previous noble gas with atomic number lesser than 20. So it is argon. Let us see argon atomic number is 18. So 6 plus 4 is 10 and these two are 18. Therefore, I can write condensed electronic configuration. Condensed electronic configuration as it is noble gas core argon 18 and what is the valence shell 4s2. So argon 18 4s2 is the correct option. Correct? Okay. In a given atom, no two electrons can have the same values of all four quantum numbers. This is called, see, we have studied all the principles. What does uncertainty principle says? It is impossible to determine both position and momentum of an electron simultaneously. So delta x into delta p is greater than or equal to h by 4 pi. What does Aufbau principle says? Filling up of the electrons into the orbitals is in the order of increasing energies. Increasing energies. Okay. So in the orbitals of increasing energy. What does Pauli's exclusion principle says? It says for two electrons, none of the four quantum numbers can be same. Or you can say it as, for an atom, if you have an orbital, the electrons, the two electrons of an orbital will have spin quantum number different, or no two electrons can have the same values of all four quantum numbers. So the given option is Pauli's exclusion principle. What does Hund's rule of Hund's rule of maximum multiplicity says? Pairing of the orbitals is not possible until and unless each orbital is singly occupied, or you can say is halfly filled. Half filled. Yes, pairing is not possible until each orbital is singly occupied or half filled. So here the correct option is option D, Pauli's exclusion principle. Correct? Okay. Next question. For azimuthal quantum number L is equal to 3, the maximum number of electrons will be. For azimuthal quantum number L is equal to 3. So they have said azimuthal quantum number L is equal to 3. L is equal to 3 means what? I'm repeating again. L is equal to 0 means S, L is equal to 1 means P, L is equal to 2 means T, L is equal to 3 means F. Please do remember this. So L is equal to 3 means which subshell? It is F subshell. Correct? Maximum number of electrons. Maximum number of electrons for F subshell. We have discussed this also. It depends on the value of M. Yes. How do we say it? 2L plus 4. So 2 3s are 6. 2 in plus 4. So 4L plus 2. This is the value, maximum number of electrons. So that is given by 4 into 3 plus 2, which comes out to 14. You can show it here also. So for M, minus 3, minus 2, minus 1, 0. Sorry, L is equal to 3. M values vary from minus 3 to 7 totally. Plus 1, plus 2, plus 3. So here spin up, spin up, spin up, spin up, spin up. Hund's rule of maximum multiplicity. 7. Spin down, spin down, spin down, spin down, spin down, spin down, spin down. So how many electrons? 14 electrons for F subshell. So for F subshell there are 14 electrons. Maximum electrons are 14. So it is 14. Next, the order of filling of the electrons in the orbitals of an atom will be. So they have given these options. It starts from third shell, and we know that order of filling the orbitals is governed by Aufbau principle and even N plus L rule. So what we say here, higher the value of N plus L, higher is the energy. Next, this is first concept. For orbitals with same N plus L value, higher the principal quantum number N, higher is the energy. Correct? So let us take option A. All the orbitals are there. 3D, 4s, 4p, 4d, 5s. So 3D, N plus L. 3 plus 2, it is 5. 4 plus 0, it is 4. 4 plus 2, it is 6. Sorry. P is 1. So 4 plus 1 is 5. 4 plus 2, it is 6. 5 plus 0, it is 5. So here, lowest energy orbital is which one? It is 4s. Okay, so I'll fill this orbital first. So this is lowest energy. it is lowest energy because n plus L value is least for this, correct, in the given options. Then we have 5, 5, 5. Out of these three, the one which has lower value of principal quantum number will have lower energy. So then comes 3D. Okay, out of 4p and 5s, which is having lower energy, it is 4p. Correct? Then comes 5s and then comes last 4d. So 4s, 3d, 4p, 5s and 4d. So this is the correct order and it comes under which of the options? It comes 4s, 3d, 4p, 5s, 4d. So it comes under option B. So we say higher the value of n plus L for an orbital, higher is its energy. However, if the two different orbitals have got the same energy of same value of n plus L, then the orbital with lower value of n will have lower energy. Lower value of n will have lower energy, right? Okay, moving to the next question. The electronic configuration of Cu, atomic number of Cu is 29. Cu is copper and atomic number of copper is 29, according to which 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d, 9. Is it correct? No, we have discussed. So here if you see, I can write it as, they have given us complete only, so we'll keep complete. If you see the last or a valence shell, 2 electrons here for D1, 2, 3, 4 and 5, filling up the electrons here according to Hund's rule of maximum multiplicity comes out like this. And we know that there is extra stability for completely filled and half filled orbitals. Therefore, the electron shifts from here to here. So the configuration comes out to 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d, 10. Yes, 4s1 and 3d, 10. Because when you shift, when one of the electron shifts from s subshell s orbital to d orbital, the d orbital becomes completely filled. It becomes completely filled, and because of symmetry and exchange energy, completely filled orbitals, or you can take half filled orbitals, are more stable. Therefore, the correct configuration for copper is what? 3d10, 4s1. You can write it like this also, or 4s1, 3d10. Both are correct. The total number of electrons that can be accommodated in all the orbitals having principal quantum number 2 and azimuthal quantum number 1. Okay, total number of electrons that can be accommodated. They have given options 2, 4, 8 and 6. So they have said the total number of electrons, how many electrons can be accommodated in all the orbitals having principal quantum number 2 and azimuthal quantum number 1. Correct. It means what? Principal quantum number 2 means it is second shell. Azimuthal quantum number 1 is for p orbital. I'm sorry, p subshell. Correct. So here it is 2p. So it means what? It means we are speaking about 2p orbitals. Yes. So total number of electrons. Total number of electrons that can be accommodated in all p orbitals, or again write 2p orbitals. See, rather than saying this and finding out 2p orbital has got 3 orientations, therefore each orbital has got, so 2p orbital has got 3 orbitals, right? 2px, 2py and 2pz, and each orbital 2 electrons, so maximum is the, so total number of electrons comes out to 6. Rather than going like this, you can use this formula, 4l plus 2. The value of L is given. So 4 into 1 plus 2. 4 plus 1 is how much? It is 4. 4 into 1 is 4 plus 2 is 6 electrons. Directly you can go for it also. You can use this directly. rather than sitting and verifying here. Okay, so maximum number of electrons for the given quantum numbers is 6. It is 6. Next question. An ion has 18 electrons in the outermost shell. It is. So 18 electrons in the outermost shell. Let us see. See, if you look at the atomic number of cesium, it is something around 50s. So it will not have 18 electrons. Whatever ion you take, plus 1 means loss of 1 electron. Thorium, atomic number 81. So it will also not have, plus 4 means around 4 electrons less. Potassium and copper. So these are the two options. Potassium has got atomic number 19 and atomic number of copper is 29. But they have said outermost shell. Outermost shell. Potassium outermost shell, if you see, K atomic number is itself 19. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 10, 18, 19. So outermost shell of potassium has got 1 electron, and that too K plus means this gone. So this will be the configuration, and outermost shell has got how many? 8 electrons. 8 electrons. So I can say these are 8 valence electrons, correct? What remains? Cu plus. Atomic number of copper is what? 29. Just now we have seen 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, sorry, 4s1, 3d10, correct? Or this can be also written as 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s1. Understanding? You can write it like this also. Okay. So they have said Cu plus. Cu plus means what? Cu plus means loss of one electron from the outermost shell. So this electron goes. So this becomes the outermost shell once those electrons are lost. So how many electrons are present in the outermost shell of Cu plus? There are 18 electrons. There are 18 electrons. So which is the correct option? It is Cu plus. Cesium, it has got one electron in its outermost shell, so doesn't become 18. Thorium is 81 atomic number. Okay. Number of unpaired electrons in n plus 2 are. Okay. Now, how to understand unpaired electrons and paired electrons? See, when you are writing electronic configuration, suppose I'll take nitrogen. Atomic number is 7. 1s2, 2s2, 2p3. And orbital diagram, spin up, spin down, spin up, spin down, and for P, it is according to Hund's law of maximum multiplicity, spin ups, correct? If the entire orbital maximum orbital has got how many electrons maximum? 2 electrons each orbital. This 2px 2 electrons, 2py 2 electrons, 2pz 2 electrons. But here I have balanced by writing these 3 electrons. So if it is having 2 electrons, we write it as spin up and spin down. This is said to be paired orbital. But if it is having, so this is also paired. But if it is having only one electron, it is unpaired. It is unpaired. For example, oxygen, if you take 8, 1s2, 2s2, 2p4 we write. So you can see here for S, paired. For 2s, paired. For 2p, I will write it as spin up, spin up, spin up, and spin down. So in 2p out of 3 orbitals, one is paired and remaining 2 are unpaired. So there are 2 unpaired electrons, I say. Understanding? For nitrogen, how many unpaired electrons? There are 3 unpaired electrons. But they have asked what? They have asked us n plus 2. That means what? Loss of 2 electrons. And that is from the outermost shell only. Therefore, the configuration becomes 1s2, 2s2, 2p1 because 3 minus 2 is 1. So here spin up, spin down. 2s also has spin up, spin down. But p has what? Spin up only. So how many unpaired electrons n plus 2 has? It has only one unpaired electron. Understood? So pairing means when both the electrons are present with opposite spins. Unpaired means when there is only one electron. When there is only one electron. So how many unpaired electrons in n plus 2? N plus 2, it is only 1. Next question. The maximum number of electrons in a subshell is given by the expression. Yes, so here I have told you number of orbitals in a subshell. Number of orbitals in a subshell is equal to, please do remember, 2L plus 1. 2L plus 1. Number of electrons in a subshell is equal to 2 into L, 2L plus 1. 2 into 2L plus 1, or I can write it as 4L plus 2. You can even verify this point what I have said. Number of orbitals in a subshell. So if you have n is equal to 1, suppose n, L, then subshell, number of orbitals and number of electrons. Okay, so for n equal to 1, L is 0, subshell is S, number of orbitals 2 into L plus 1, 2 into L plus 1. Number of electrons 4L plus 2. Okay, so L is 0, 0 plus 1, 1. So S subshell has got only a 1 orbital. 4 into 0 plus 2. So it is having only 2 electrons, number of electrons. N is equal to 2. L is equal to 0, L is equal to 1. Don't worry about 0. Let us talk about 1. It is P subshell. So 2 into 1 is 2, 2 plus 1 is 3. Are there 3 orbitals or no? Px, Py and Pz. Number of electrons, 4 into 1, 4 plus 2 is 6 electrons. Correct? Each orbital will have 2 electrons each. For third one, we know it is 0, 1 and 2. For 2, it is D. Number of orbitals, 2 2s are 4, 4 plus 1, 5. D has got 5 orbitals or no? Yes. 4 2s are 8, 8 plus 2 is 10, 10 electrons. Is D having 10 electrons maximum? Yes. 4, 0, 1, 2 and 3 is there. For 3, it is F subshell. 2 into 3, 2 3s are 6, 6 plus 1 is 7. Are there 7 orbitals for F? Yes. So F subshell has 7 orbitals. Number of electrons, 4 into 3, 12 plus 2 is 14 electrons. Is it verified? Yes. So what we say, number of orbitals is governed by the formula 2 into L plus 1. Whereas number of electrons in that given subshell is governed by 4L plus 2. How that 4L plus 2 came? 2 into 2L plus 1. 2 into 2L plus 1. That becomes 4L plus 2. So the correct option is what? It is 4L plus 2. Next question. The number of spherical nodes in 3p orbitals. Again, the question on nodes. Yes, there are two types of nodes as discussed. It is radial nodes, which are also called spherical nodes, and planar nodes. Okay, number of radial nodes is n minus L minus 1. Number of planar nodes is L. Total nodes are n minus L minus 1 plus L. So minus L plus L gets cancelled. So total nodes are n minus 1. Correct? So they have given 3p orbital. And they have asked us total of spherical nodes. For p orbital, for p, L is equal to 1. Yes, for p, L is equal to 1. So number of spherical, or you can say radial nodes in 3p orbitals. So it is n, 3 minus 1 minus 1. So how much? It is, answer is 1. So there is one spherical node. What about planar node if they would have asked? Planar node, it is L, that is equal to 1. So total nodes, n minus 1, that is equal to 3 minus 1, that is equal to 2. So they have asked us radial nodes. So it is 3 minus 1 minus 1, that is 1 radial node. So 3p has 1 radial node, that is a spherical node. one planar node. So total nodes comes to 2. Is that right? Total nodes come to 2. So let they give us any orbital. You should be able to identify. You should be able to identify how many spherical nodes, how many planar nodes. Yes, those should be identified by you. You should be able to identify them. Okay. Next question. A near UV photon. A near UV photon of 300 nanometer is absorbed. A near UV photon of 300 nanometer is absorbed by a gas and then re-emitted as 2 photons. One photon is red with wavelength 760 nanometer. Hence the wavelength of second photon will be. Wavelength of second photon will be. So how do we do it? Okay, so how do we do it? So they have said there is a photon, UV photon of 300 nanometer. It is absorbed by the gas and then re-emitted as 2 photons. It is re-emitted as 2 photons. Okay. Okay. Then one photon is red. One photon is red and its wavelength is given. Wavelength is 760 nanometers. Okay. Wavelength, second photon. What they have asked, the wavelength of second photon. They have asked us the wavelength of second photon. Okay. So how do we do it? Now see, we know that the total energy E or E total is equal to E1 plus E2. Correct? This is known to us. And we also know that E is equal to h nu. But since it is in wavelength, I can write E is equal to hc by lambda. Correct? Okay. So if E1 is equal to hc remains constant, I can write it as 1 by lambda 1. E2, I can write it as 1 by lambda 2. So I can substitute here. So E total is equal to 1 by lambda 1 plus 1 by lambda 2. How much is the total or E total is nothing but what? E total is equal to 1 by lambda total wavelength. So I can write here instead of E total 1 by lambda T. How much is the total wavelength of the photon which was absorbed? 1 by 300 nanometers is equal to, what is the wavelength of first photon? 760 nanometers plus lambda 2. Find the wavelength of second photon. 1 by lambda 2 is equal to 1 by 760 1 by 300 minus 1 by 760 nanometers. Solve it out. You will get the option. It is 496 nanometers. You will get 496 nanometers. The wavelength of second photon will be 496 nanometers. Yes, you can solve it. So the formula here, so here what formula I've used? E is equal to E1 plus E2, or I can say 1 by lambda is equal to 1 by lambda 1 plus 1 by lambda 2. So this is 300 nanometers. Here it is 760 nanometer and you have to find lambda 2. So it comes out to 496 nanometers. Next question. The transition in He plus ion, that would have the same wave number as the first Lyman series in the hydrogen spectrum. Again, an interesting question. He plus ion they have said. Okay. So let us see how we can solve. We know that wave number is equal to RH into Z square when it is for hydrogen like ions, 1 by N1 square minus 1 by N2 square, correct, per centimeter. Yes, For hydrogen, mu bar is equal to RH. 1 square is 1. 1 by N1 square minus 1 by N2 square. Okay, per centimeter. For helium, it is RH. Helium atomic number is 2, so 2 square. 1 by N1 square minus 1 by N2 square. So it is 4 times per centimeter. So it is how many times? 4 times. So which option gets 4 times? So it is 4 to 2 transition. This will have same wave number as the first Lyman line in the hydrogen spectrum. It will have same wave number. The ratio of radii of the first 3 Bohr orbit in hydrogen atom is, the ratio of the radii of the first 3 Bohr orbit in hydrogen atom is. So it is being given here itself. So here, how do we write the ratio of first 3 Bohr orbits? Yes, so radii, Rn is equal to, we know that it is A naught n square, or in some of the explanations I had taken R naught n square, where R naught is called Bohr's radius. It is called Bohr's radius. Yes, so I can write it as, so Rn is equal to A naught n square. So here we can say what is radius per year direct. This is called constant 0.52 picometers. So I can say it is directly proportional to n square, correct? It is directly proportional to n square. So if I take 3 Bohr's radii, R1 is to R2 is to R3. So first this is 1 square, second orbit 2 square, is to third orbit 3 square. So this comes out to 1 is to 4 is to 9. So the explanation is already given there. 1 is to 4 is to 9. So it is option C which is correct. Next question. An electron of velocity, say some velocity v, is found to have certain value of de Broglie wavelength. The velocity to be possessed by the neutron to have same de Broglie wavelength. There is an electron with some velocity v. Yes, it possesses the de Broglie wavelength. They are asking velocity of the neutron to possess same de Broglie wavelength. So I can write de Broglie wavelength lambda is equal to h upon mv. And what is v equal to? We know that c is equal to nu into lambda. So c is what? Speed of light, but here I can take it as v. So v is equal to nu into lambda, correct? Therefore, what will be lambda equal to? Lambda equal to v by nu, correct? Lambda equal to v by nu. Okay, so can I substitute it here? So v by nu is equal to h by mv. H by mv. Therefore, v is equal to or frequency is equal to, this v comes here, mv square upon h, correct? What is mv square? We know that kinetic energy is equal to half mv square, but I want mv square, so I will take it here. So mv square is nothing but 2 into kinetic energy divided by h. Yes or no? We know this. 2 into kinetic energy divided by h. Therefore, I can say frequency is equal to 2 into kinetic energy divided by h. So 2 into kinetic energy divided by h. So which holds the correct option? And what is the energy given? It comes out to, when you solve it out, it comes out to option D, 2 into kinetic energy divided by h. So what we do, so we know the value of mass, electron they have said, we know the value of v, so we will keep it this as a constant nu, and we will find the value. So it comes out to 1840 divided by nu. 1840 divided by nu. Okay, next question. So here I solved it out for the next question. So electron of velocity, okay. So solve it out. See, wavelength of electron, de Broglie wavelength of the electron is equal to, use this formula, wavelength of neutron into h upon mass of neutron into velocity of mass of electron into velocity of electron. Yes, that is nothing but h upon mass of neutron into velocity of neutron, because they have said same de Broglie wavelength. Yes, therefore I can use this. So I can find the velocity of neutron is equal to, from this formula, how I can find the velocity? Mass of electron into velocity of electron divided by mass of neutron, because this gets cancelled. Understanding from this formula, wavelength of electron is same as wavelength of neutron. So h by m, mass of electron into mass of velocity of electron is equal to h by mass of neutron into mass of velocity of neutron. Understanding, both wavelengths are same. If HH gets cancelled, I want to find velocity of neutron. So velocity of neutron is mass of electron into velocity of electron divided by mass of neutron. Substitute all the values. Mass of electron 9.1 into 10 raised to minus 31 kg into velocity of electron, we know 2.16 into 10 raised to 16 divided by mass of neutron 1.67 into 10 raised to minus 27. So when you solve all this, you will get 1840, and that divided by velocity. Yes. So this is the correct option. This is the correct option. Understood? Okay. Next question. This is the frequency of matter wave is equal to nu is equal to frequency. V is the velocity of the particle. As I discussed, I told you just now. So we know that lambda is equal to what? H upon mv. So this is the explanation for this question. And we know that velocity is equal to, I will make it V as velocity. Velocity is equal to nu into lambda. That is C is equal to nu into lambda. Therefore, lambda can be written as V by nu, correct? I'll substitute this in this equation. I'll get V by nu is equal to H by mv. H by mv. Yes. So therefore, what I will do, frequency is equal to V comes here. I'm taking it reciprocal, mv square upon h. What is mv square? It is related to kinetic energy. We know that kinetic energy is equal to half mv square. Therefore, mv square is equal to 2 into kinetic energy. So I can write it as 2 into kinetic energy divided by h. Therefore, mu is equal to 2 into kinetic energy divided by h. So option B is the correct option. Option B is the correct option. Yes. Next, the ratio of kinetic energy to potential energy of an electron. So they have asked the ratio of kinetic energy to potential energy of an electron in Bohr orbit. So in Bohr orbit. So this is the question. In Bohr orbit of hydrogen-like species. Okay, so how do we find this? The ratio of kinetic energy to potential energy. Fine. So let us take here. Kinetic energy in Bohr's orbit, they have said. So it is Z into E square by 2R. This is the formula. Bohr's model, according to Bohr's model. Potential energy, it is Z into E square by R. Yes, so they have asked us the ratio of kinetic energy to potential energy. So let us take it, kinetic energy by potential energy. So Z E square by 2R, the whole divided by Z E square by R. So Z E square, R gets cancelled. What remains? 1 by 2. So kinetic energy is to potential energy. The ratio is 1 is to 2. It is 1 is to 2. But here, if you see, when we speak about the potential energy, it comes out in negative form for Bohr's orbit, right? Therefore, I can write it as 1 by 2, the whole divided by minus 1. Understanding? Potential energy. Energy of the electron in Bohr's orbit is given by, this is the potential energy, minus. Kinetic energy is always positive, so it comes in minus. So I will keep minus here. So I'll take it as minus Z e square by R. So 1 by 2 divided by minus 1 comes out to minus 1 by 2. Therefore, I can write it as minus 1 is to 2. So which is the correct option? The correct option is option B. This is the correct option. So I have hopefully I have done all the questions. I have taken maximum questions from this topic and have done around 75 questions for structure of atom. If I get few more questions, I'll surely consider those questions. So all the concepts what I have discussed with you all, please practice all those concepts. Apart from that, all the formula have to be properly managed. Once you get to know the formulae of the different concepts in this atomic structure, it will be easy for you all to solve lot many questions on the similar basis. So what I have done is I have taken concepts, and on that I have taken the questions. According to me, I have covered all the concepts. And from the structure of atom, expected questions are 3 questions. Maximum expected questions are 3, or minimum is 2. So maximum. So this is having a good number of questions. So maximum expected questions from structure of atom are 3. And I hope whatever the syllabus is being provided for the structure of atom, I have covered all of it. Starting from atomic number, isotopes, isobars, concept of shells and subshells we have seen, dual nature of matter and light, that is de Broglie relationship we have seen, Heisenberg uncertainty principle we have seen, Bohr's model of an atom we have seen. So many formula come under Bohr's model. Concept of orbital, Schrodinger wave equation we have seen. In Schrodinger's wave equation, we have discussed about quantum numbers, principal quantum number, azimuthal quantum number, magnetic quantum number, spin quantum number, and all the concepts regarding that. Shapes of the orbitals we have seen. Majorly concentrate on S, P, and D, because F has got complex shape, we don't have it. Rules for filling up of the orbitals we have seen. Aufbau principle, Pauli's exclusion principle, Hund's rule of maximum multiplicity. And last, electronic configuration of the atoms, writing the complete electronic configuration or condensed electronic configuration or orbital diagram, yes, representing in the form of blocks. And lastly, the extra stability of half-filled and completely filled orbitals. Yes, on all the concepts I have covered the questions. So in the next class, we'll be taking, if possible, I'll be taking up the next set of questions, or we will directly go to the next topic. Hope you have cleared with this. Thank you.